Okay, so we're back. We learned about asymptotes, right? Tangent has these asymptotes. If we can, however we can, find two consecutive asymptotes, meaning two asymptotes that are like right next to each other, one right after the next, then tangent, we find the halfway point, that'll be the inflection point. Sometimes it's the x-intercept, sometimes it's not. Then we find the halfway point between those, like a quarter point. That will involve taking the tangent of something pi over 4, so 1 or negative 1. And that will either give us a graph going up or a graph going down. In this case, maybe let's do one that's going down. If it goes down on that side, I know it goes up on this side, and we have one period of tangent graph. Okay, so the key to all of this is that very first step, finding two consecutive asymptotes. And that's where we're going to jump off with this one, okay? We can call them tricks if you want. I mean, a lot of this stuff is going to be the same. D is going to be a vertical shift. We will say tangent really doesn't have an amplitude, since amplitude is the distance between max and min. That's what we've defined it as. So we have an A value. It might stretch it out a little bit, but no amplitude. And then this guy right here, we're going to call this the argument. What I'm taking the tangent of. Tangent of bx minus c. Tangent of this argument. If we turn this argument into pi over 2, or 3 pi over 2, or negative pi over 2, then tangent would be undefined. Okay, because the tangent of pi over 2 was undefined. We can't do that. We're dividing by 0. The tangent of 3 pi over 2, undefined. Can't do that. Tangent of negative pi over 2. Remember, negative pi over 2 is coterminal with 3 pi over 2, so we can use either one of those. But that will give us those two consecutive asymptotes. If whatever this is equal to pi over 2 or negative pi over 2 are the ones we're going to use. You could use 3 pi over 2 as well. So what we're going to do is we're going to figure out what values make that happen. If I set the argument equal to pi over 2, and I set the argument equal to negative pi over 2, and I solve these little equations, whatever gets kicked out for x, whatever x is, those are going to be asymptotes. We force them to be by doing this. So then we have two consecutive asymptotes, and then we can roll from there. We can find our inflection point, we can find the quarter point, and then we can kind of play our little detective game and connect the dots. So let's go through an example. Here's what we're going to do. We're going to graph y equals a half tangent of x over 2. Okay, we're not finding the period. Where we started sine and cosine by finding the period of this thing, we're not going to do that. We're going to set the argument x over 2 equal to pi over 2 and equal to negative pi over 2. That should be the first step. That will be how you earn at 1 point. Maybe graphing this on a test is worth 5 points. I'll look and see if you did this first, because that's the first step to doing it. You find two consecutive asymptotes. From here we solve, okay? I'll multiply by 2 to get x by itself. The 2's cancel. Multiply by 2, the 2's cancel. And we're left with vertical asymptotes at pi and negative pi. Okay? Let's graph that. So here's that. Here's pi. Here's negative pi. This is what we've done so far. Okay? Next, halfway between those will always be an inflection point. So halfway between pi and negative pi, well, it's 0. If you didn't know that, if you ever want to find the halfway point between two things, thank you, bell work, you add the two things together and divide by 2. So that's what I was doing here. To find our halfway between, I'll add them together, 0, divide by 2, 0. So now my inflection point will be at 0. If you notice, if we go through and plug it in, 0 divided by 2 is 0, tangent of 0, 0, 0 times a half is 0. We'll get a root in this case. The times we would not get a root would be if it was a vertical shift. If I had a plus 7 right here, we would go through all that stuff and we would get 0 plus 7. So it would actually be 7, and I'd have to move this point up. So it's not always a root. It is in this case. From here, let's do some more pattern seeking. Let's check this out. I can go inflection point at 0, asymptote at pi. So if I go that same distance away, I'm going to get another inflection point. Inflection point at 2 pi. How about the other way, right, with symmetry? So at negative pi asymptote, at negative 2 pi, another inflection point. And we almost have all the makings to finish this thing now. I'm a little neater about it on this one, so we'll do this one. There's what I just drew, basically. We have our inflection point, asymptote, inflection point, asymptote, inflection point. We need our quarter points now. I need enough information. I know it has to go through this dot and approach this line, but never quite get there. So will it do it going up this way? Or will it do it going down, going this way? So that's what we need to figure out. So if I just find what's halfway between 0 and pi, I can make that happen. Okay, well, halfway between 0 and pi is pi over 2. Okay, so I'm going to go back to my original equation, looking for it. Here it is. And I'm going to plug in pi over 2 in for x. I'm going to take the x out and put pi over 2 in there. Okay, so pi over 2 is pi over 4. Told you guys, you just got to do all the pi over 4s. Okay, the tangent of pi over 4 is just 1. That's a 1 square root of 2. 1 times a half is a half. So we're at this point. If I plug in a pi over 2, it would give me a half. If I plugged in negative pi over 2, it would give me negative a half, because that would be negative pi over 4. And we're left with this. Here's me plugging in pi over 2, just like I went through, and I would get a half. Here's the other one on the other quarter point. You don't always have to do, you don't have to do 2 quarter points, but at first I'm showing you guys where this stuff is coming from. Negative pi over 2, negative pi over 4, tangent negative pi over 4, negative a half. So now it's our detective game. I know my graph has to go through this dot, has to go through this dot, and has to approach this line but never quite get there. Okay, it's going to go up like this. Occam's razor. Sure, there are things in life that hit and turn around, but this isn't one of them. This is going to hit this and then approach the asymptote in the infinite direction. On the other way then, it's going to go down. Okay. We put it all together, and we have 2 full periods. Here's 1 full period. If it approaches going up on one side, it approaches going down on the other. If it approaches down on one side, it approaches up on another. There's 2 full periods of our 1/2 tangent x over 2, I think is what we were doing, okay? Let's do one more example. Why don't you hit pause on this one, take it as far as you can take it, and then come back, and we'll do it together. Pretend like you can't see any of this. Okay, you're back, I think. Or you just sat there and waited, whatever. The first step to these, if it was a sine or cosine, the first step is find the period, break it into fours. For tangent and cotangent, the first step is to find the consecutive asymptotes. Find 2 asymptotes, and then we'll start doing the halfway stuff. So to find 2 consecutive asymptotes for tangent, we set the argument, in this case 2x, equal to pi over 2 every time, and equal to negative pi over 2 every time. It's pi over 2 and negative pi over 2, no matter what, every time. So we get this little equation. Okay. 2x equals pi over 2, 2x equals negative pi over 2. We solve those and we get 2 consecutive asymptotes, one at pi over 4 and one at negative pi over 4. From there, we find the halfway point between them. Halfway point between those 2 would be 0. And then we just do a little pattern recognition. Okay. So here's my pattern recognition. If I'm going 0, pi over 4, 2 pi over 4. So 2 pi over 4, that's pi over 2. 0, negative 1 pi over 4, negative 2 pi over 4, negative 2 pi over 4, negative pi over 2. And then be careful here. Some students will sometimes put 2 asymptotes between those, and it doesn't. It goes inflection point, asymptote, inflection point, asymptote, inflection point, asymptote. It bounces back and forth between those 2. So this is what we have so far, a little skeleton. We found 2 consecutive asymptotes, then we did some halfway between them to get our inflection point, and then some pattern recognition to get these 2 other inflection points. Okay, we're not quite out of the woods yet. We need to find the quarter point. So the quarter point between 0 and pi over 4, I'm asking what's halfway between those. Halfway between those would be pi over 8. So I am actually going to go into my equation, and I'm going to plug in a pi over 8. Wait, Mr. Edwards, I don't know how to do the tangent of pi over 8. That's good, because we got to multiply it by 2 first. 2 times pi over 8, pi over 4. The tangent of pi over 4 is 1. 1 times negative 3 is negative 3. So this is actually, when we plugged in pi over 8, this is going to go down to negative 3, wherever negative 3 is. From there, we know it's going to go at pi over 8, it goes down on one side, so it has to go up the other way. If it falls on one side of the asymptote, then it has to go up on the other side. If it goes up on one side, it has to fall on the other side. 2 full periods of negative 3 tangent to x. This is what they look like. I didn't give you any on these that have a shift to them, a horizontal shift, but it's the same idea. The fraction work is probably a little bit tougher, okay? And it is tougher, but it's the same process. We can do this. Let's go through and practice. Bring your questions to me. Here's your guys' next part of your next stamp. Again, 4-6 is really long. We have tangent, cotangent, secant, cosecant. but I want to start you off with tangents. So it's going to say use a graphing calculator. Do not. Practice these. We will do some more practice in class. Moving on.